a vector is a quantity which has magnitudes. What do I mean by magnitudes? Size, brilliant. Magnitudes and direction. So the direction is important. Okay. Now, all the different ways I could write down a vector. Let's say I have a vector that A to B. I'm going to put a little line on the top of it to tell me that it's a vector, which means not only has it got size, it's got a direction as well. And I can represent that by using a column. And let's say it's 3 across and 1 up. Okay, so that is me writing down a vector. But I could also represent that as an arrow, which is an arrow that's 3 across and 1 up, something like that. That goes A to B. So that arrow there is a vector A to B like that. Okay, so that's a vector. What I'm going to do is quickly talk about unit vectors. Let's say I have an axis in 3D, because we can talk about vectors in 3D as well. And this is going to be X, Y, and Z. Well, the vector AB, the one we just drew, would be a vector that's 3 in the X direction and then 1 in the Y direction. So we've got 3 in the X direction, 1, 2, 3, 1 in the Y direction. It's going to be an arrow that looks something like that. That's the vector AB. Okay, can you see that? We also have some special vectors. If I have a vector that's got just a length of 1 unit in the X direction, I could write that as 1, 0, 0. What do we call that? Can anyone remember? I. Okay, so a unit unit vector in the X direction we call I, and I'll put a little hat on it like that to show it's a vector. In the Y direction, J. So J is going to be 0, 1, 0. And then in the Z direction, 1 unit, it's going to be K. And that looks like that, 0, 0, 1. Okay? Does everyone remember doing that? Okay. That means that if I come back up here, it gives me a third way of writing my vector out. I've got this first way, where AB is 3, 1 in a column. I've got a way of writing it or expressing it as a picture, geometrically as an arrow. And I can also write that AB is equal to 3 lots of I, 3 in the X direction, plus 1 lot of J. Okay, so those 3 things are equivalent ways of talking about the same idea. Does that make sense? Okay, so we'll quickly just talk about multiplying vectors. Yeah, if you need to. So multiplying by a scalar, firstly. So that's quite easy to do. Let's say I have some vector, I'll call this one R, is equal to, I don't know, 3, 2. Okay. If I want to multiply by a scalar is just a quantity with just size. So 2R, 2 lots of R, that's been multiplied by 2, would be 2 lots of 3, 2. And what I do is I just multiply the 3 by 2 and multiply the 2 by 2, so I get a vector 6, 4. Okay, what does this mean if I draw it out? Well, R is going to be 3 across and 2 up, which is something like that. So 2R, what's 2R going to look like? This is now 6 across and 4 up. Yeah, it's just the same direction, but it's now twice as long. So that's what it means in that sort of sense. So if I want to multiply a vector by a scalar quantity, I just multiply all the numbers in the column by that. Okay. Or again, I can write this out as this is now 6i plus 4j. Okay. Let's quickly talk about addition, and then we'll stop and we'll do some questions. So addition of vectors. Addition of vectors. Let's come up with a couple of vectors. I've got A. What should we have as A? Let's have 2 and 3. And let's have another vector B. And this one can be, I don't know, 1 and minus 2. Let's go like that. So let me just draw the vector A. 2 across 3 up, that's something like that. And B is 1 across and 2 down, which is something like that. Let me just move it up a little bit. Okay, that's my B vector. So let's see if we can start talking about adding and subtracting these things. Well, first of all, let's come up over here, let's do A add A. Well, I can do it as the column. That's the same as 2, 3 plus 2, 3, which is 4, 6. So that's A plus A is the same as 2A. So it just means that I get the vector A. That looks like that. And when I add vectors, I just take the arrow and I put it on the end of the other arrow. So I've got another vector A, and I get a vector that, and then the addition of the two vectors is equivalent to one arrow like that, 2A. Does that make sense? Okay. If I wanted to add, before I do A add B, let's do A take away A. Well, this is the same as 2 over 3 take away 2 over 3. So what vector do I get then? 0, 0, yeah. Okay, which is basically saying this: if I have the vector A, and remember what I said, if you want to add these vectors, then you get the next vector, and you put it on the end of this one and add it on. Well, minus A as a vector is minus 2, 3, and we've already talked about multiplying by a scalar. This just makes it minus 2 over minus 3, which means it's an arrow that points the opposite direction like that. Okay, so it means I end up with nothing, which is what we said. Okay, so what I'm basically saying is a negative vector is just an arrow with the same magnitude that just points the opposite way. Okay, and then finally we'll talk about A plus B. Well, geometrically, that's me taking the vector A and then adding on the vector B, which looks like that. And the result is a vector A plus B, which starts here and finishes there. That vector there is A plus B. And in terms of what is actually going on, A plus B is 2, 3 plus 1 minus 2. It gives me an outcome of 3, 1. So 3 across and 1 up, which is what that vector is. Okay, so that's how we do all that sort of stuff. So we have two vectors, O to A, 7, 3, and O to B, minus 2, 5. First thing I'd like you to do is see if you can just draw them. Okay, just draw the two vectors. Now these are called position vectors. Why are these position vectors compared to the other ones? Let's start from origin. So O is always 0, 0. So it's going O to A. Okay. So see if you can draw them first, and then we'll see if we can ask some questions about them. Okay, did you all get something that looked like that? Yeah, sort of. Is that okay? So because these are position vectors, it's a vector that goes from O to A. O is the origin, and then A would be a point there. Now, one thing you've got to be careful of is vector is not the same as coordinate. Okay? A vector is basically showing you how to get from O to A, if it's a position vector. Right, first question then. Should we try this? Question 1 is going to be, what's, this one should be quite easy. What's OA plus OB? Harry, do you want to tell me the answer to that?
Yeah.
Yeah. These are vectors though, not coordinates, okay?
Yeah. Sorry.
Add them, yeah. Okay. So what do I get as a outcome?
5.
Yeah. 5, 8. Okay. Now I'm just going to draw it up on here what we would do, okay? O to A plus O to B is the same as going from O to A, so along here, O to A, and then once you're here, adding on O to B, which is like something like that, here. And so O to A plus O to B is this vector here, starting from where you started and finishing there. So that vector there is OA plus OB. Okay, and it says you go 5 across and 8 up. And it should be the equivalent thing. Okay, can you all see that? Okay, good. I'm just going to clear that off so we can do some more questions on the same thing. Okay, next question then. Can you tell me, I want to know, what is the vector A, B? What is the vector to get from A to B? Anyone remember how to do that? It's not quite. Go on then, Sam. Yeah, it's A to B is the same as going from O to B and then taking away O to A. So a way to remember it is, if you want the vector A to B, it's O to the second one, O to B, take away O to A. If you wanted the vector B to A, it would be O to A, take away O to B. Okay, does that make sense? Let's just see why it is that. Okay, we can do the same thing on the graph as we did before. We are suggesting that the vector A to B, this line here, or this vector here, A to B, is the same as the vector of you going O to B, which is that, and then taking away O to A. Well, O to A is this vector here, you can see, O to A. Well, minus O to A will be the same vector but pointing the other way around, added on the end, which is something like that. Do you agree? Does it need to come down a little bit further? Looks about right to me. Okay. And so if I draw that on, O to B, take away O to A, I get a vector that looks like that. Now, are those two vectors the same, A to B? They look the same, right? Okay. So let's just see if we can work it out then. O to B is minus 2, 5, and then we're going to take away O to A, which is 7, 3, minus 9, 2. Okay, cool. Good. Is that okay? Now this this thing here is probably worth remembering. This is like a general way of finding the vector that from A to B. Okay, or the other way around. If you wanted B to A, it would be O to A take away O to B. Okay. Got it? Okay, third question then, before we move on. I think we'll do one more in 3D. The third question I'm going to get you to do is this. Can you find for me the magnitude of AB? What's the magnitude? What do I mean by the magnitude? Yeah, how long is the arrow? Yeah, yeah.
Magnitude 2.
Magnitude of the vector A to B. How long is that arrow there, A to B? Yeah, brill. Okay. So the way to find the length of something is just use Pythagoras. So the length A to B is going to be the square root of -9, that's the distance in the x direction, plus the distance in the y direction. So I think I'm going to get 81 plus 4. Is that right? So I've got the square root of 85. That's the length of that, or the magnitude, you'd say. But it's the same thing, it's the length. Okay, any questions on those then? So shall we do the same sort of thing again, but shall we change it to 3 dimensions, and then we're going to talk more about the dot product. Okay, so shall we have position vectors again? So we'll have O to A. What do you reckon for this? Anybody? 3, 2, 6. Okay. And we'll have O to B again.
1, 2, 3.
Should we have a minus one? Yeah, minus 4. Okay. Right, first job then is, do you want to have a little sketch of it? See if you can sketch it. Let's do OA plus O to B. Okay, should be able to do that pretty quick. Vlad, what do you get? Say again? Yeah. 4, 4, 2. Yeah. Okay. And let's just illustrate that on there. What it means go O to A. So go along here, O to A, and then take this vector O to B, which is something that comes, oh, excuse me, more like that, right? That's more like O to B. Okay, and it says you go 4 down, 4 this way, 1, 2, 3, 4, 4 across this way, 2, 3, 4, and then 2 up to there. Okay, so that's so this vector here is O to A plus O to B. Okay, let's just clear all that. Everyone agree with that? Okay. Next question. What was the next thing we did? Oh, can you tell me the vector A to B? How do I work that out? Can you remember? It's O to B minus O to A. So that's going to be 1, 2, minus 4, take away 3, 2, 6. And what do I get? Minus 2. Is that 0? And minus 10, is that right? Okay, so that's the vector A to B. Basically saying to get from A to B you need to go minus 2 in the x direction, don't change in the y direction, and go 10 down in the c direction. Okay. Good, and again, can you find the magnitude then? What's the magnitude? Darren, can you talk me through that? Yeah. 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 Brilliant. Okay. So it's just like Pythagoras in 3D. X squared plus y squared plus z squared. So I'm going to get the square root of 4 plus 100, yeah? 104. Square root of 104. Okay, any questions? So we started talking about this last lesson. This is called the scalar product. But usually people just call it the dot product. And we talked about, you know, what it was and what you could use it for. But mainly, all you're going to do on your questions is just apply it. Okay, just use it. And there's two ways we can do the dot product. There's two ways you can work it out, and that's going to be the trick to doing the questions with the dot product. Okay, I'll show you the two methods again to remind you, and then I'll just show you how it could be useful. So let's say you have two vectors. Again, we'll call them A and B. So I'm going to use capital A, and these can be, we'll go straight into 3 dimensions. These could be, I'm just going to label them up, A1, A2 and A3. So some numbers associated with the A vector. And then we've got a B vector as well. And this is going to be B1, B2 and B3. Okay. Well, the first way we can talk about the dot product is, firstly, this is how you write it down, A dot B. That's that dot is the operation we're doing. It's not the same as just multiplication. It's a type of multiplication, multiplication of vectors, because vectors aren't just numbers. They have the direction as well. There's a special type of multiplication. It's called the dot product, and it gives you an answer which is a scalar. It gives you an answer which is just a number. So the answer you get at the end is not a vector. It's just it just has some magnitude. It's just a number. Okay. And the first way we can do it is we can say that A dotted with B is the same as me saying it like this: A1, A2, A3 dotted with B1, B2, B3 is just this: A1 times B1 plus A2 times B2 plus A3 times B3. If they're just two-dimensional vectors, then it's just A1, B1 plus A2, B2, or it works in 4 dimensions, or however many dimensions you want. Usually we use 3 because it's what you use. Okay, so that's the first definition. And if you do that, you will get an answer, and it will be a number, and that's it. It's a scalar. But there's another way of doing it, and the other way of doing it will give you exactly the same answer. Okay, and we give you 2 ways of doing it so you can work certain things out. The second way of doing it is this. Again, we're going to do A dotted with B. Make your dots quite big, I would suggest. Okay. And the other way you can get the same answer is if you do the magnitude of A times by the magnitude of B. Now the magnitude of A isn't a vector either, because it's just going to tell you a length. So because it's the Pythagoras bit, it's the magnitude, it's the length. Magnitude of B is just a number. And then you get cos theta. Okay, and can you remember what the theta was?
The line
It's basically the angle that is made between the two vectors. So if I have vector A, and it looks something like that, and I have vector B, and I put them next to each other like this, the angle that is made between the two vectors is the angle theta. Okay? So those two equations, the top one and the bottom one, will give you the same answer and tell you the same thing. But one is in terms of multiplication of the vectors in the columns, and the other one's in terms of the angle between them. Okay? Have you got it? Any questions? Well, shall I show you what we can do then? And again, I'm just going to ask you for two vectors. Let's have a vector A. Are we going to do this in 3 dimensions? Taz, what do you reckon for this vector? Anything you want? Anything? 1, 2, 3? Okay. And what about B? 4, 5, 6. Okay, fine. Right, let's see what we can do. My job, and the question I'm giving you is, I've got two vectors here, A and B, and they're both arrows. And let's say I put the arrows next to each other. I want to know what the angle they make between them. What's the angle between them? Okay, that's the question. Do you understand? Okay, so the way I would do it is this. I would do the dot product, because the dot product is the only thing that I know about with vectors that is linked with an angle. Okay, so I'm going to do the dot product of A and B, and what I'm going to do is I'm going to work out what the answer is. Now, do I know what the angle is? No, that's what I'm trying to find out. So I can't use the second formula to get me an answer. It's up there, isn't it? Sorry. I can't use this second formula to get me an answer because there's no theta. I don't know it. I can use the top formula, can't I? I can use that top formula for the scalar product and it will give me an answer. A1, B1 plus A2, B2 plus A3, B3. So let's have a look. I'm going to do the dot product on A and B. So this is going to be 1 times 4, which is 4, plus 2 times 5, which is 10, plus 3 times 6, which is 18. Do you agree? So I've got my dot product of A and B gives me an answer 14 plus 18, 32. Okay, so the dot product of A and B is 32. Gives me a number. Okay? Do you agree with that? Okay. But from the second definition of the dot product, the second way of working it out, I know that A dotted with B is equal to the magnitude of A times the magnitude of B cos theta. But now I know that whatever it is, the answer is 32, because I've got two ways of working out the same problem, you see. So, cos theta must be 32 divided by the magnitude of A times the magnitude of B. So what we're going to do now is we're going to try and work out what the magnitude of A and B are. But we've already done this, okay? So, let's have a look. Let's do it over here. Magnitude of A. Let's go back up and have a look what A is. Oh, the magnitude of A then is 1 squared plus 2 squared plus 3 squared, which is, let's have a look, 1 plus 5, is that 14?
Yeah.
So that's going to be root 14. And the magnitude of B is 5 squared plus 6 squared. Sorry, I've missed one out. And plus 4 squared, isn't it? Okay. So that's 16 plus 25 plus 36. So what's that for? 77. Are you sure about that? 16, 77. Is it?
Yeah.
77. Okay, go on. Okay, so because I have two ways of working out the scalar product, I just did it using the vectors to get my answer, and then I used the other way of working it out and rearranged it to get to this point here. And what I've found is that cos theta, the angle between the two vectors, is 32 divided by root 14 times root 77. So can someone just work that out for me? You can give it me as a decimal, yeah, that'd be fine. Radians, please. No, don't worry about the angle first. Just get me a value for what cos theta is. 0.975. Okay, and now obviously finding the angle is pretty straightforward. Theta is cos to the minus 1 of 0.975. In radians? Anybody? Or in degrees? I don't mind really. 0.224.